Alright. On these proofs, the goal is going to be to prove lines parallel. Okay? So we're going to be using things like corresponding angles, alternate interior, alternate exterior, those kinds of things that we've been talking about. Okay, so if we look at this first example, we're given two different pairs of angles congruent. Okay, so my first statement is the given. So just like we've been doing, the reason my first line is given. Okay, and I mean, we talked about also labeling the diagram, right? So if they tell us angle 1 and angle 2 are congruent, we can put the same number of arcs in those angles to show that on the diagram. And then we're also told angles 1 and 3 are congruent. So I can put one arc in there as well. Okay? So now, they say, well, if 1 and 2 are congruent and 1 and 3 are congruent, then 2 and 3 are congruent. So this, we're going to have to think back a little bit. So which property lets me say that if two things are congruent to the same thing, they're congruent to each other? Okay? That's the transitive property. Okay? We could also use substitution here. Okay, but the transitive property is the one that lets me say if two different things are equal or congruent to the same thing, then they're equal or congruent to each other. So now, what we're saying is we've concluded angles 2 and 3 are congruent to each other. Then they're saying AB and DC are parallel to each other. If these two angles are congruent, why am I allowed to say those lines are parallel? Okay, so this is one of those relationships that we talked about yesterday. Right? We said things like, if corresponding angles are congruent, then lines are parallel. Or if alternate interior angles are congruent, then lines are parallel. If alternate exterior angles are congruent, then lines are parallel. Right? So what is the relationship between these two angles here? Will they be corresponding, alternate interior, alternate exterior, consecutive interior? They're going to be alternate interior. Okay? And it might help to visualize if we kind of extend these lines out. What do you mean when they're both lines? So I'm talking about angles 2 and 3. So I'm saying we know angles 2 and 3 are congruent. Therefore, we can claim these lines are parallel because if alternate interior angles are congruent, then lines are parallel. Angles. So we're going to write that whole thing out. If alternate interior angles are congruent, then lines are parallel. Okay, that's our reason. That's our justification. So in these proofs, okay, they're really similar to the ones that we worked with before, except now our goal is going to be to prove lines parallel. So usually our final reason is going to be about corresponding or alternate interior, consecutive interior, or alternate exterior. Okay. So once I was able to show that angles 2 and 3 were congruent, then we can say those lines are parallel because alternate interior angles are congruent, then lines are parallel. Okay. Questions on that one? Okay, so let's take a look at the second one then. Okay, we'll do this one together as well. So here I want to prove two different sets of lines parallel. Okay, so this is kind of like two proofs just mashed into one, because I'm proving two different sets of lines parallel. They give me two different pieces of information, right? Angles 1 and 5 are congruent, and angles 15 and 5 are congruent. So they actually split that up over two lines. Right? So this first part, okay, we always want to look for the givens first, remember. So angle 15 is congruent to angle 5. That's given. Well, then they tell me the other given is going to go in line 5. So I'm going to go ahead and write that one in as well. Angle 1 is congruent to angle 5. Okay, so now let's look through and see what we've got. So next, okay, in line 2, they somehow claim that 13 and 15 would have to be congruent. That doesn't really follow from 5 and 15 are congruent, but why can we claim that 13 and 15 are congruent? They're vertical, right? So I can just say angle 13 is congruent to angle 15 by the vertical angles theorem. Okay, the vertical angles theorem just says vertical angles are congruent. Well, now somehow they claim that 5 and 13 are congruent to each other. Sebastian? It's going to be transitive. Right? If we look back at lines 1 and 2, I've got both 5 and 13 congruent to the same thing. So if two different things are congruent to the same thing, they're congruent to each other at the transitive property. So now, from that, they claim R has to be parallel to S. So let's look at the diagram here. What they said is angle 5 is congruent to 13. Okay, they're both down here on line M, so I can ignore line L up here. Right? What's the name of that relationship? Why am I allowed to say R is parallel to S? They're corresponding angles, right? So here I can say R and S are parallel because if corresponding angles are congruent, then lines are parallel. Okay, so we've got half of our goal done, right? We proved R is parallel to S. Now we just have to prove L is parallel to M. So they say the other given was that angle 1 is congruent to angle 5. Okay, and they even tell us that those are corresponding angles, right? If corresponding angles are congruent, then the lines are parallel. So the lines that would be parallel here are L and M, right? So now I can just claim L to be parallel to M. Okay, we should understand, that whatever we want to prove should be at the end. Okay, we proved half of it in line 4. The other half would just have to go at the end. Okay. Questions? All right. Then